Hello everybody, this is a presentation about the Hit2Gap project. Here are some details about myself. My name is Miguel Blanes and I work as a researcher at the National University of Ireland, Galway. I work as a project manager for the Hit2Gap project. NUIG participated in this project in three different areas. Firstly, by providing one of the pilot sites, the Alice Perry Engineering Building. We also developed and validated a novel reduced order model to help energy managers to generate whole building energy baseline for testing different energy conservation measures or to keep track of the building's energy performance. Lastly, we developed Moscow, which is an online web application that enables final users to develop their own reduced order models. This application was integrated in the final platform as one of the Hit2Gap modules. Regarding the Alice Perry building, this is an example of a successful collaboration between universities and industry. The building, which hosts the School of Engineering at NUIG, was built with the idea of serving as a living laboratory. With this in mind, the Hit2Gap project was an opportunity to put the whole building as a testing ground for the different technologies of the project. We enabled data acquisition with the help of Cylon and built a comprehensive database that gathers data from nearly 1,800 sensors at a 1-minute interval. This enables nearly real-time applications. Several technologies were tested at this pilot. Loads forecasting and fault detection and diagnosis by University of Girona. Principal components analysis tools were developed by Fraunhofer Institute in Germany. The ESPR simulation was used by the University of Strathclyde, and finally the Moscow tool that was developed here at NUIG. The pilot was also used by Irish partner Sutec to develop a 3D BIM-based energy visualization. Currently, the Alice Perry building database continues to store data that can be used for research purposes. This data is available upon request and after the evaluation of your research proposal. Please contact us. We want to hear your ideas. Regarding the Moscow tool, this tool provides with an interface for the reduced order model developed during the course of the project. This slide shows the application architecture. The application was developed using the Django framework. The reduced order model is embedded as a functional mockup unit in a simulation engine that uses a complex range of dependencies, such as Python modules and libraries, and other software based on C++ or even Fortran code. The application stack is fully developed using non-proprietary software. The simulation's execution and interfacing with the Django application is orchestrated using Celery as an asynchronous task scheduler and RabbitMQ as a message broker. Here we show some screenshots of the final user interface of Moscow. Users can develop their own reduced order models using the forms and information provided. They can run the models, visualize results, and use the tool to calibrate the model against real data. You can also use the graphs visualization tool to compare model results with other versions of the model, to keep track of energy faults, or to assess energy conservation measures before their implementation. If you want to know more about the Hit2Gap project, there is a dedicated community in Zenodo that gathers all publications and communications produced during the project. In the case of adapting a module to the platform or learning about the BEM server protocols for data and software integration, code is available also on GitHub. If you want to know about the Alice Perry database or want to use the Moscow tool for your project, please drop us an email. We want to hear about your projects. Many thanks for your attention.